He's our kibitzer. He tries to keep me straight, but I think it's the other way around.
Yeah.
Okay. So we'll talk about station setup and some of the equipment that you need. This tends to be a little more for a base station HF, but it, could still be a base station for VHF and UHF. Obviously, you need a transceiver.
We don't see the PowerPoints.
You don't see the slide?
Negative.
Ooh, it says we're sharing. Well, let me.
You're sharing your file manager thing.
How about now?
There it is.
It is there.
Oh, now I'm back to.
It needs to be enlarged a little bit. It's not the right size.
Ooh. Not being fun, is it?
Had that problem last week.
I tried the F5.
Well, they're all grayed out. No. All right. What's going on?
You're the computer guy. You tell us.
I just used to design them. I don't like to use them.
Now you know why the rest of us don't like to use them.
Especially if it's Microsoft related.
Yeah.
All right. Can you see that one?
There you go.
Yeah.
All right. Like I said, obviously the most important thing is a transceiver, whether it's a handheld or a base station. If it's a base station, in most cases, it's going to need a power supply. Today's radios don't come with a 120 volt AC plug on them. You have to have an external power supply, and they're set up so they can be essentially mobile. They run on 13.8 volts, which is your nominal, like car battery voltage. So you can take your base station out in your car and hook it up if you'd like. If you want to do any of the digital modes, you're going to need some form of computer. Could be a laptop, a desktop, something like a Raspberry Pi, possibly your phone, although it's harder to hook up to do digital modes.
You can Bluetooth in a lot of cases.
You're going to need some other things like a microphone. In the case of a Handy Talkie, it's built in a base station, it's not. Maybe speakers, headphones, cables to hook it all up. And then you need to look at grounding. And we talked about that in the safety thing, but some of the same grounding stuff. If it's a base station, all of your equipment needs to be tied to that single point ground that goes to an outside ground.
What do you mean by ground?
A connection to earth ground, essentially a ground rod that's driven into, and usually you can go to Lowe's or Home Depot, or maybe even Ace sells them. They're 8 or 10 foot, half to 5/8 inch rods that you drive into the ground and make a connection to.
And why do you need it?
Yes, one.
Why do you use them?
In order to connect one side of all of your equipment to earth, so that if you have any like a close by lightning strike or anything like that, it tends to shunt it to ground instead of through you or other things. Your service panel at your house will also have a ground rod if you look close to where your power meter is. And there'll be a ground line going down to that ground rod. And normally that should get tied to a ground rod at your station entrance and have those all tied together. The point is you want to keep everything at the same potential. So if there's anything that causes a high current on the ground side, it's going to raise the voltage. So you want the voltage on everything to be the same, so there's no difference in potential. And then last but not least is an antenna.
Question on your power supply, if you're pulling out a 120, you haven't, and you can step it down with an inverter, correct?
Yeah.
Power supply, yeah.
Yeah, most of the power supplies you're going to use for a base station put out 13.8 volts up to 14. Sometimes they have a small adjustment.
So Bob, when you're talking about potential, you're basically talking about voltage. One analogy might be if you're on a 1 foot step and you fall on another 1 foot step, you've only fallen, the same height. If you're at 200 foot steps and you fall from one, you still fall the same height. But if you fall from a 100 foot step to a 1 foot step, then life is not good. And that's what burns up your equipment. But that electrical potential is different.
And if you were touching it,
You would know.
you could be
You're a good grandmother.
the, so a typical transceiver puts out about 100 watts for HF. Most of the VHF, UHF may be less than that, 50 or 75. I think my 9700 puts out 100 watts at 2 meters and 75 at 70 centimeters and like 50 at 1200.
That'd be 1 amp at 100 volts, would be 100 watts.
70.7 volts RMS.
RMS.
And typically it draws at 100 watts about 18 to 20 amps. You're normally going to be less than 50% efficient. So if it's a 100 watt radio, you're going to need at least 200 watts power into it. So that's one of the things you use to size the power supply. Although in most cases, what they sell are 20, 25, 30 amp power supplies typically. So that's already sized for most 100 watt radios.
But that's at the DC output.
Right. 13.8 times 20 amps. So you're over 200 watts in. You obviously want to use as short a wire as you can and heavy gauge up to a point where it's just too hard to deal with. I mean, the heavier the better, but there's a limit on, you don't want to rot 2-aught welding cable.
The
It's
shortest
kinda hard.
possible, as large as fact.
Because that at 20 amps, just a small amount of resistance is going to give you a significant voltage drop. And I've actually tested mine. If my radio is getting down to 12 volts, it really starts putting out a lot of harmonics. I tested it once just to see. And normally they specify the operating range at like 12.8 to 14.8. The high end could blow a fuse internally or cause it to shut down or some damage. So when you do a power supply, and typically you're going to get one that's 13.8 volts. You want to calculate what the minimum power is that you need. So if you had a 50-watt transceiver, which is not atypical of a car radio, if you do the calculation, you need at least 7.25 amps minimum. So when you go find a power supply, you want one that's puts out more than 7¼ amps, just to be safe, to have some margin. And the reason I put that calculation on there is there's a question, because we're not totally done with math,
Darn.
That's what I said.
but it's simple multiplication and division. So why are short, heavy gauge wires used for a transceiver's DC power connection?
Alpha,
I would go with alpha. Okay,
Hmm.
which of the following is an appropriate power supply rating for a typical 50-watt mobile FM transceiver?
Ooh.
Charlie.
Something.
Only,
Huh? Yeah, now, it's another one where there's two that obviously are wrong because power supplies and transceivers don't run on 24 volts.
Okay, could be problem.
I think, I was.
Isn't it like half of the output?
Can't understand. Yes, the old.
I'm thinking at a delta.
Yeah. Delta.
I think we're trying to do it between the fuse and the power supply, but yeah, Delta would definitely do it.
Definitely would do it.
Hmm.
And it's greater than 7.25 amps at 13.8 volts.
And I'm terrible at math.
Okay, well, we said it was a 50-watt transceiver. So we'll assume it's 50% efficient. So we multiply by 2 and say we need 100 watts.
Yeah,
Okay, so 100 watts, your Ohm's law, your power formula, excuse me, is the watts divided by the voltage is going to give you the current. And we know that the voltage typically is 13.8 volts. So it comes out a minimum of 7.25 amps.
And that gives you a little bit of room.
Okay, like I mentioned, if you want to do any of the digital modes, you need a computer. There's, in some cases, some of the newer SDR radios, like the one I'm getting ready to build, has a computer built in, so you don't need an external computer. In most cases, you do. So you have to know how to hook it up. And you need to connect the audio, receive and transmit, and some keying signal. In other words, like equivalent of your push to talk to when you transmit or receive, between the computer and your radio. Now, most of the modern radios have a USB connection, and they basically do virtual audio. So you still have on the computer setup, you'll have a virtual speaker out and a virtual microphone in on the USB channel. And you connect that to the setup on the radio, just the opposite. So you'd have your computer's speaker out or audio out, normally they call it speaker out, to the microphone input port on your transceiver. And the output on the transceiver would go to your microphone input port on the computer, whether they're physical cables or you're doing it over USB. And then there's the, if it's not USB, you'll have a third control line for your push to talk or transmit or receive. You're normally in receive, and you normally ground a connection to put it in transmit mode. And that's taken care of over USB also. But basically, just think output to input input to output. This is showing one of the little QRP single board radios. I believe this is a kit phaser. And how you would hook it up, this with physical cables. So you'd have speaker out from the laptop going to your audio in on the board, and the audio out on the board going to your microphone input.
The blue and the pink or the blue and the green?
What signals are used in a computer radio interface for digital mode operation?
Charlie.
Brenda?
I'm reading.
I wish I had a cookie to eat.
You're too fast.
Okay, how are transceiver audio input and output connected in a station configured to operate using FT8? That's one of the digital modes. And you connect it the same way for all of the digital modes.
Boy, I think I know the answer to that one.
You do? Well, don't let them know. Don't give them a hint.
What could it
Because
be?
said audio, but input and output of the computer. Input, output.
Bravo.
Bravo.
Oh. Yeah, I think we talked about WSJTX last week, and FT8 is one of the modes.
Something I remember last week.
Okay, which of the following connections is made between a computer and a transceiver to use computer software when operating digital modes? This is where you got to get them straight.
That's one you always have to have right.
Alpha?
I did that one wrong.
We're still guessing here.
Yeah.
Remember, in, out, out, in?
That's what I was thinking.
Line out, computer line out. Transceiver line in, computer line out. I was,
I'm going Charlie.
One of the few that we haven't done.
And you're right.
oh,
Come on.
line in.
Yeah. Yeah, sometimes they label it line in instead of microphone in on the computer. Okay, so we did the power supply and the transceiver and the audio connections. Now we need the actual cables to hook them up. And one of the problems you can have, because you may have a lot of RF running around, depending on whether you have common mode RF coming back down on your coax or just leaking out from your transceiver or other equipment, possibly from a loose connector. Could be lots of sources where you have RF.
Do you want to show her your RF on your wall wart? Your choke on your wall wart?
Oh, well, I don't know that they can see it.
No, that they can, that's right in the middle of the cable. You put your hand on it, goes down.
This one?
Yeah.
Well, but. All right, Byron wants you to see, well, they're not seeing the camera anyway.
No, even the people here, because they may not know what
Oh.
it looks like.
That's just a molded on ferrite bead. You can get clamp-ons.
So it's not just a thing for amateurs.
All right. In fact,
So even
the
though-
better USB cables come with one on each end molded on.
Oh.
But they cost a
Yeah.
little more.
Actually, I just bought one of those for the new radio.
So one of the things, and it's kind of recommended that you put ferrite chokes or beads, preferably on each end of the cable. You can't really have too many ferrite beads. You can buy them as what they call clamp on, it's split. And so that you can put it over a cable, and it clips together
Mhm.
where it's not as good as a whole one, yes,
Mhm.
because you do lose some of the magnetic characteristic because of the split,
Mm.
because it's two halves. But it's kind of hard to get them over a large connector and then still have it kind of
We
fit
were
on.
talking about that when you would do the splits out in the field and to keep them from the.
No, they
rain, you
just-
would do the clamp like that, if that would
I don't know that I have
keep
any.
them waterproof. You know,
No, they don't
the
have to be
connectors.
waterproof.
That was just waterproof in the connectors.
Yeah.
Yeah.
Yeah. Although you didn't bring yours
I
again.
didn't bring it.
The one Dan had
the one
last
that I
week
built-
that he made,
I
was-
put a heat shrink over it, and then knowing that the heat shrink wasn't gonna shrink all the way down over the cable on the ends
Mhm.
because of the size of the ferrites, I put, some RTV 3145 inside to fill it, so that it would waterproof it. Now,
Okay.
the only reason I did that is because I didn't want water to get in there and then just sit there and stay, because it would be outside if I
Okay.
put it on an antenna. And what Bob said about you can't really have too many is true, but there's a video that I watched on YouTube, and I can't remember the name of the owner of the video, but he did a test to see how many is probably the best number to put on there. And he started with one, and he said he was using this test setup where it showed how much reduction you had, how many dBs of reduction you had on each added ferrite.
Okay.
And 1, 2, 3, 4, and 5 all had a very significant reduction. The sixth ferrite that he put on was much less, and the seventh was so minimal, there's almost no difference. I used that information and said, well, I've got 12 of them, so I'm gonna make two chokes, each with 6.
We had 6 on the one we had
Yeah.
there last weekend, we
Yeah.
had 6.
Yeah.
so and like I said, you can buy them. A lot of sources, Palomar Engineering sells them through DX Engineering and HRO and other places. A little pricier,
Yeah.
they're better quality, but you can get an assortment off of eBay
Mhm.
for relatively cheap. You know, $10-15, you get a box full of different sizes that are all clip-on. And they, you know, they work. Use 2 instead of 1.
And for the price difference,
Yeah.
you put on the extra one.
In most cases, they work. Now, you can't always depend on stuff made in China.
Yeah.
Some's good, some's not so good.
I'm getting from this talk that this is rather common.
Mhm. I think she was asking if they were common, rather common.
Oh, yeah. This is a picture of some assorted ones. These are all what we call clip-on. And you can see the 2 in the middle are unclipped so that you can use whatever size is appropriate for the wire that you're going to put it on. In some cases, if you use one with a larger inside diameter, you can run the wire through it several times. So it has the same effect as having multiple beads.
And that's actually better if you can do multiple turns. I forget when you're wrapping it through,
Mhm.
there's something about you do not want to take up more than 80% of the inside area.
Okay.
You know, so after you keep stuffing it, it stops being useful after a while.
Right.
Something about the surface area inside the toroid.
Okay.
just like after n number of beats.
Yeah.
There's diminishing returns.
The wire through there a couple of times.
Yeah, the one on the top,
There's enough-
it's kind of an odd one, but it's got several wraps through it.
Yeah,
But he was saying at some point in time, you can't
It's
leave it
diminishing
anymore,
returns,
you should overdo that 80%.
Right.
The other thing about doing multiple wraps through there is if you're putting it on a coax to reduce common mode choke, to reduce common mode currents. Your coax has a bend radius that you have to pay attention to. Yeah, you don't wanna violate that.
Right. Okay, which of the following could you use to cure distorted audio caused by RF current on the shield of a microphone cable?
Delta.
Delta.
Everybody got that.
That was an easy one. Okay, we talked about grounding. And it kind of helps, prevents having ground loops since everything is at the same potential. So there's no, if there's no current, voltage difference between different components, then you have no current flow. If there was a potential difference, you could have a current. That current creates, if it's varying, creates a varying magnetic field, which can cause other problems, coupling and so ideally you want to have everything on a single point ground.
And what exactly should be ground, like outside of ham radios?
I'm not sure.
what should be grounded, was that the question?
Yeah, you say what should be grounded besides ham radio equipment?
Yeah.
Well, actually, you should do it with everything as just good practice. The same reason applies. It's not unique to ham radio.
If every 3-prong plug in your house is something that's grounded, the stuff that only has 2 prongs is double insulated,
They claim.
they claim.
Yep.
So.
Well, The 3-plug is pretty common here in the US now, so that means everything is grounded, right?
Yeah, with the 3-prong plug, assuming that you don't have an old house, that your wiring actually has the ground wire. There's a lot of cases, if it's really old, somebody may have put a receptacle in with 3 prongs, but the ground pin may not be connected to anything.
I found them, they fake the ground back to the.
Yeah, that's bad.
Yeah.
Yeah, if your house was built in the 60s or later, it's probably not a problem that you'll see. You don't have a ground and someone putting a 3-prong receptacle. But 50s and earlier, yeah, you don't know what you're running into.
And, you'll see a lot of these little 3-prong to 2-prong adapters for cases where you don't have a 3-prong receptacle, but you got a 3-prong appliance, and they'll have a little tab that you connect to the screw on the plate, which doesn't really go anywhere other than the box itself. May not be connected to anything else.
It's a feel good thing.
Until
it's not. Until it's not.
It's recommended to use flat copper strap to connect these things together or braid. It's much easier inside to use flat braid. Flat copper strap is a little harder to deal with and a little more expensive. But that's really recommended when you go out to your ground rod.
What
The flat copper strap. Braid doesn't work as well outside because it corrodes, because it gets water in it.
Did you strap, is that the round or just a flat strap? On your copper ground?
Most of it the braid you buy for ground strap is flat.
I think we all use ground paper.
So how do you connect the ground rod to your mobile setup?
It's called the chassis ground in your car. But you should connect directly to the negative side on the battery.
You can do that.
That's a test question.
No,
And here's a picture of copper strap and ground rod. I
Now,
mean,
with
ground
that-
braid, and it's usually tinned. It's copper, but it's tinned, so it doesn't
Look,
corrode as bad. I found I use 1/2 inch to connect most things. And if you roll the end of it up, you can put it in a ring tongue terminal for a number 6 gauge wire and crimp it. So you've got a terminal on each end. And most of your radio equipment will have maybe a 1/4 inch ground lug. So you can get them to fit over that easy.
Does Nuclear Dave, KU0R still talk to you? With your poor ground connection?
I haven't seen it.
So, back to the last slide again, for outdoor use.
mhm,
Okay, so the strap is recommended for, or not, the flat strap there is
Right.
recommended for outdoor use.
Right.
What's the hazards of using a heavy gauge copper wire?
Oh, it just doesn't have as much surface area.
mhm.
Gets back to our
Yeah.
earlier discussion of skin effect, which we haven't talked about with these guys. Where depending on the frequency and the voltage, current travels on the surface of the conductor.
And
So-
lightning is going to look for the least path of resistance,
Mhm.
and you want that path to be the ground and not your radio.
Because if you remember from one of the first days, when we talked about charges. Where when you have current flowing, okay, you've got free electrons, which are negatively charged. Well, negatively charged or negative charges, okay, repel each other. So that's what forces the electrons to the outside surface because they're trying to get away from one another.
Mhm.
Which of the following conductors is preferred for bonding at RF?
I don't know.
Well, if Byron doesn't know, we're in trouble.
Think I need a donut.
Let's go with flat copper strap. Now, if you can't get flat copper strap, you can use heavy gauge wire. Actually, I would think heavy gauge stranded, like number 6 stranded, is better than number 6 solid, has more surface area.
Yeah. Of course, if it's a Dave, it's 4 off.
Right. I'm cheap. I just ran 6 gauge.
Yeah.
That was expensive enough.
You aren't nuclear like Dave.
I know. Okay, so we learned about power supplies and how to size it. You want to make sure that you have more amp capacity or power capacity than the equipment you're supplying to. And normally you're looking at less than 50% efficiency on the radio. For digital modes, you need to remember how to hook up the audio cables out to in to out, and a separate signal for push to talk or keying, also called transmit receive. To get rid of noise, one of the best things you can do is use ferrite beads. Either get cables that already have them installed, which you can buy for your normal audio or USB cables, you can buy them that way. Or you can get the clip-on ferrite beads and do it yourself. And connect everything to a single point ground.